There's a mixture of problems all throughout chapter 2 in preparation for the test. So just a review of a lot of stuff that you've had. Okay, getting back to 2.8, 41 through 44 that I had in a previous video about points where the function was not differentiable. So for 41, -4 was a corner point, and 0, the function was discontinuous. 42, -1 was discontinuous. 2 was a corner point. 43, 1 was discontinuous. 5, you had a vertical tangent. 44, -2 was a corner point. 1, the function was discontinuous. And 3 was also a corner point. So I think I didn't have it written down last time, but here it is written down now. Okay, now getting back to a lot of stuff that we did in previous sections. Okay, going back to 3.427, limit as x approaches 0 if absolute value of x is equal to 0. Given epsilon greater than 0, find delta greater than 0 such that 0 less than absolute value of x minus 0 is less than delta, implies absolute value of f of x, which is absolute value of x minus 0 is less than epsilon. Okay, but absolute value of x, we said, is the same thing as absolute value of x is less than epsilon, and that already matches this side, so let delta equal epsilon. So 0 less than absolute value of x minus 0 less than delta implies absolute value of x minus 0 is less than epsilon. So that's it. Okay, 2.621, find this limit. First multiply it all out, 4x to the fourth plus 4x squared plus 1 over x minus 1 squared is that. Distribute to x squared plus x. Comes out to be this mess. 4x to the fourth plus 4x squared plus 1. And then if you multiply that all out, you get all of this. Okay. And then what you do is divide top and bottom by x to the fourth. Since these are both fourth degree, divide top and bottom by x to the fourth. So you end up with limit x approaches infinity of 4 plus 4 over x squared plus 1 over x to the fourth divided by 1 minus 1 over x minus 1 over x squared plus 1 over x cubed. Now when x approaches infinity, that's 0, that's 0, that's 0, that's 0, that's 0. So you basically just have 4 over 1, which is 4. Okay, 2.415. Limit x approaches 3 of 1 plus 1/3 x is 2. Okay, given epsilon greater than 0, find delta greater than 0 such that 0 less than absolute value of x minus 3 is less than delta. Implies 1 plus 1/3 x, that's f of x, minus L is less than epsilon. So I work on this. That's the same as 1/3 x minus 1. Okay, if I multiply both sides by 3, I get this. So absolute value of x minus 3 is less than 3 epsilon, and that matches that. So let delta equal 3 epsilon. So if you give me epsilon is 0.01, delta will be 0.03, and so on. Okay, then retrace our steps. 0 less than absolute x minus 3 less than delta implies delta being 3 epsilon, change that to 3 epsilon, then multiply both sides by 1/3. So I have 1/3 absolute value of x minus 3 is less than epsilon. Distribute to 1/3 x minus 1 inside, and then rewrite this in this strange fashion just for the rules of the game. 1/3 x minus 1 is the same as 1 plus 1/3 x minus 2 is less than epsilon. Okay, and then let's see. 2.237. Limit as x approaches pi over 2 from the right, 1 over x cosine x. So pi over 2 is 1.5702. So you want, coming from the right, numbers that are larger than pi over 2. So 2, 1.6 to the 10th, 1.58 to the 100th, 1.571 to the thousandth, and so on. You can see from the regression that the numbers get bigger and bigger negative, so negative infinity is the limit. 2.661, y equals x to the fourth minus x to the sixth. Factor out x to the fourth, 1 minus x squared, x to the fourth, 1 plus x, 1 minus x. So the zeros are 0 and plus or minus 1. Okay, it's an even function, so I can just focus on here. Okay, if I plug in a super big number, that's positive. That's negative, so it goes to negative infinity. If I plug in 0.5, positive, positive, so it goes above. And since I know it's an even function, I have symmetry with respect to the y-axis. So I have something that looks like that. Okay. 2.729. F of x is this. Find the derivative at 2, 2. So f prime of x, limit h approaches 0, 5 times x plus h over 1 plus x plus h squared, minus f of x all over h, multiplied by 1 over h. Copy this, copy this. This side needs 1 plus x squared, top and bottom. This side needs 1 plus x plus h squared, which happens to be 1 plus x squared plus 2xh plus h squared. And multiply all this mess out, you get all that. Multiply this, I change that to a plus and a negative. Distribute, and you get all this. Okay, 5x cancels, 5x cubed cancels. Okay. And then if you take that one, and that one, and factor out, you have h parentheses 5 minus 5x squared minus 5xh. H cancels out. Okay. Now take the limit as h approaches 0. That becomes 0. That becomes 0. So I have 1 plus x squared squared. So 5 minus 5x squared over 1 plus x squared squared. That's my derivative. You want me to plug in 2? Plug in 2. Negative 15 over 25, negative 3/5. So y minus y1 equals m times x minus x1. Okay, so that's that one. We may have actually looked at that before. Okay, and then let's see. (2.743) at t equals 4. The velocity means derivative. So I find the derivative of this. Again, no shortcuts. Those of you who know the shortcut, you can't use it. You must use the limit definition. So f prime, limit h approaches 0 of 80 parentheses t plus h minus 6 parentheses t plus h squared minus the original function all over h. Distribute to 80. T plus h squared is that. Distribute to negative 6. 80t plus 80h minus 6t squared minus 12th minus 6h squared. Copy, copy. These two cancel out. These two cancel out. That one, and that one all have an h. Factor out the h. 80 minus 12t minus 6h all over h. Cancel, cancel. Now I can plug in h is 0. So 80 minus 12t is a derivative. Those of you who know the shortcut, you could double check with the shortcut, but you have to show me this on the test. Okay, then I plug in 4. So 80 minus 12 times 4, 80 minus 48. So 32 meters per second is the velocity and also the speed. 2.745, find the equation of the tangent at the point 2, negative 4. So y prime is limit h approaches 0, f of x plus h, 4 parentheses x plus h minus 3 parentheses x plus h squared minus parentheses 4x minus 3x squared all over h. This is 4x plus 4h minus x plus h squared is all that. Distribute the negative 3 on the next step. 4x plus 4h minus 3x squared minus 6xh minus 3h squared minus 4x plus 3x squared. 4x cancels, 3x squared cancels. That one, that one, that one all have an h. Factor of the h, recurring theme, cancel that h. So I have limit h approaches 0 of this, plug in 0 for h, 4 minus 6x. Okay, now I'm at the point 2, negative 4. I plug in x is 2. I plug in y equals negative 4, but there is no y to plug in. So the slope is 4 minus 6 times 2, negative 8. So y minus y1 equals m times x minus x1. 2.1 number 3, y equals 1 over 1 minus x at 2, negative 1. To give you this whole long table, so I plugged in some numbers, 1.999 and negative 1.001 repeating. The slope comes out to be y2 minus y1 divided by x2 minus x1, which is 1.001 repeating. So our guess for the slope of the tangent line is 1. So y minus y1, y minus a minus 1 equals m of 1 times x minus 2. 2.625, limit as x approaches infinity of radical x plus 3x squared over 4x minus 1. Divide top and bottom by x. Divided by x outside means divide by x squared inside. So this gives me limit x approaches infinity of 1 over x plus 3 over 4 minus 1 over x. Now when x gets big, that's 0, that's 0. So I end up with radical 3 over 4. Okay. And then we have see, 17 on limits. Limit x approaches negative infinity of x minus 2 over x squared plus 1. Divide top and bottom by x squared. This gives me 1 over x minus 2 over x squared, all over 1 plus 1 over x squared. When x approaches negative infinity, that's 0, that's 0, that's 0. So I end up with 0 over 1, which is 0. 41, limit as x approaches infinity of this. Okay, I can switch that ln and the limit. In other words, take ln of the limit. Okay, and then divide top and bottom by x. So ln of the limit x approaches infinity. This is 1 over x plus x over 1 over x plus 1. So now when x gets big, that's 0, that's 0. I have the limit as x approaches infinity of x. That's infinite. Ln of the big number is also a big number. So the answer is infinity. Okay, 2.827. Find the derivative of the square root of 9 minus x. Again, no shortcuts. So limit h approaches 0 of radical 9 minus parentheses x plus h minus radical 9 minus x all over h. Multiplied by the conjugate of the numerator. So just copy this, except make this a plus, top and bottom. So that's like a minus b, a plus b. So I square this, 9 minus parentheses x plus h, minus parentheses 9 minus x, all over h times all this stuff, radical 9 minus x plus h plus radical 9 minus x. 9 cancels the 9, x cancels that. So I am left with a negative h. Negative h cancels that h, so I'm left with a negative 1 on top. So limit h approaches 0 of negative 1 over radical 9 minus x plus h plus radical 9 minus x. Now I plug in 0 right here, and the bottom is radical 9 minus h plus another radical 9 minus x, I should say. So I have 2 radical 9 minus x. That's like a plus a is 2a. So radical 9 minus x plus another radical 9 minus x is 2 of them. The 2.4, number 20, prove this limit. So write the usual given stuff, given epsilon greater than 0, blah, blah, blah. Okay, so let me just get to the essence. 0 less than absolute value of x minus 10 less than delta implies absolute value of 3 minus 4/5 x minus a negative 5 less than epsilon. Okay, so I work on this, clean that up. I get 8 minus 4/5 x. Okay, I've got to force that to look like that. Okay, well, I need to make this just x, not 4/5 x, so I multiply by 5/4 on both sides. So multiply by 5/4. Okay, I turn these around. These are opposites. Notice this is 8 minus 4/5 x. This is 4/5 x minus 8. They're opposites, but when you have the bars, then they have the same absolute value. Okay, so I have 5/4 times absolute 4/5 x minus 8. And that gives me x minus 10, which is exactly what I have here. So that delta equal 5/4 epsilon. Okay, so retrace my steps. 0 less than absolute x minus 10 less than delta. Okay, then I turn this around. Absolute x minus 10 is the same as absolute 10 minus x. Is less than 5/4 epsilon. Multiply both sides by 4/5. This is epsilon. This is 4/5 of absolute 10 minus x. Distribute in 8 minus 4/5 x, and then just rewrite this the way that we wanted to, which is absolute value of 3 minus 4/5 x minus a minus 5 is less than epsilon. That end of proof. Okay, it's weird, but that is the same as 8 minus 4/5 x, as we can see over here. Okay, 2.8, number 5, they give this as the original function. So large positive slope, small positive, 0, large negative, small negative. So here's x versus f prime, large positive, small positive, 0, large negative, and then coming back to a small negative after that. Okay, then I already showed you this one using Pascal's triangle, but that derivative came up before x cubed. 2.629, limit as x approaches infinity of radical x squared plus ax minus radical x squared plus bx, multiply by the conjugate, radical x squared plus ax plus radical x squared plus bx over the same thing. Those are ditto marks there. I ran out of space. But the bottom now has that. So it's this thing squared, which is that, minus this thing squared, which is that. X squared cancels out. So I now have ax minus bx over all this stuff. Divide top and bottom by x. And to do that here, underneath the radical, x squared. So this becomes a minus b this becomes radical 1 plus a over x plus radical 1 plus b over x. And now when x approaches infinity, that goes to 0, that goes to 0. Square root of 1 plus square root of 1 is 2. So final answer is a minus b over 2. Okay. See 2.2, number 25. Limit as theta approaches 0 of sine of 3 theta divided by tangent 2 theta. Okay, so I plugged in plus or minus 0.1. I got that. Plus or minus 0.01, 1.499. So the guess would be 1.5. Okay, let's see, 2.415. We may have already done that. Limit x approaches 3 of 1 plus 1/3 x is 2. Given epsilon greater than 0, find delta greater than 0, such that 0 less than absolute x minus 3 less than delta implies absolute 1 plus 1/3 x minus 2 is less than epsilon. So I fit it with this. That comes out to be 1/3 x minus 1. I got to make it look like this. So I multiply by 3 on both sides. And I get x minus 3, which is right here. So that delta equal 3 epsilon. So proof, 0 less than absolute x minus 3 is less than delta. Change delta to 3 epsilon. Divide both sides by 3. 1/3 absolute x minus 3 is less than epsilon. Distribute to 1/3 in. And then rewrite it in the funny fashion that it makes it look like that. So absolute 1 plus 1/3 x minus 2 in absolute value is less than epsilon. Okay, 2.325, just a setup. Oh no, not a setup. I actually worked it out. So to find this limit, again, multiply by the conjugate. That's a recurring theme. So that's radical 1 plus t plus radical 1 minus t. That's a minus there. So I get this thing squared, 1 plus t, minus this thing squared, 1 minus t, over t radical 1 plus t plus radical 1 minus t. Okay, the ones cancel out. I have t minus a minus t, which is 2t. That t cancels that t, giving me 2. Okay, over radical 1 plus t plus radical 1 minus t. Now I can plug in 0. So put a 0 there, 0 there. 2 over radical 1 plus radical 1, 2 over 2, 1. 29 for this limit. First, you need a common denominator. So multiply top and bottom by radical 1 plus t. So I have 1 minus radical 1 plus t over t times radical 1 plus t. And then a similar theme, multiply top and bottom by the conjugate of the numerator, which is 1 plus radical 1 plus t divided by 1 plus radical 1 plus t, etc. Okay, so you work out the rest of that. 41, it's a piecewise defined function. So x squared for x less than 1, we know x squared is parabolic. This is the point negative 1, 1. And then between negative 1 and 1 inclusive, f of x is x, straight line, closed circle, then x greater than or equal to 1, 1 over x, which follows like so. And so the only point of discontinuity is that x equals negative 1, but the function is continuous from the right in this particular case. Okay, that should be like so, I believe. Okay, but it gets covered up right over here. Okay, let's see, 49b. F of x is x cubed minus x squared minus 2x over x minus 2 at a equals 2. So you know the function is not continuous at x equals 2. Can we make it continuous? Okay, so we factor x times x squared minus x minus 2, which is x times x minus 2, x plus 1 divided by x minus 2. Cancellation, x times x plus 1. So this function is the same as this function except at x equals 2. So how do I remove the discontinuity? Well, let f of 2 be 2 times 3, which is 6. So if f of 2 is equal to 6, that removes the discontinuity. Okay, 55, intermediate value theorem. E to the x equals 3 minus 2x at 0, 1. So I subtract 3 and add 2x. So the function is e to the x plus 2x minus 3. So f of 0 is 1 plus 0 minus 3, which is negative 2. That's less than 0. F of 1 is e plus 2 minus 3. That's e minus 1. That's greater than 0. So one side is positive, one side is negative. So by the intermediate value theorem, there is a c somewhere between 0 and 1, such that f of c is 0. Here's the picture. F of 0 negative, f of 1 positive, continuous function. So it has to cross the x-axis somewhere to calling that c. Okay, then I think the last one I have is 2.627. Find this limit. So multiply top and bottom by the conjugate again. So we've seen that game before. So square that, 9x squared plus x minus 3x squared is minus 9x squared. These cancel out. So I have x over that square root, divide top and bottom by x. So divide this by x underneath the radical, divide by x squared, and that's just by x. So it's a limit as x approaches infinity of 1 over radical, let's see, 9 plus 1 over x plus 3. And now when x gets big, that's 0. So I have 1 over radical 9 plus 3, which is 1 over 3 plus 3. So the final answer is 1/6. Okay. All right, so this is a mixture of problems for review from chapter 2 in preparation for the test.